Hey YouTube, Jay Kilroy here. Hope everybody had a good and Merry Christmas, stayed safe, enjoyed themselves, ate too much food. Back in the shop, we got a new toy. We got a 3D printer. Here's some parts, parts that I've printed. Always been intrigued by the technology of 3D printers, wanted to play around with 3D printers. I guess you could say it's the only CNC machine in the shop. So, you know, without further ado, let's get the camera over to the machine. Let me show it to you. All right, here is the machine. The machine is a LulzBot Taz 4. I bought it, the pre-assembled model, so I paid the premium price but got the minimum headache. There's plenty of unboxing videos out there on the LulzBot Taz 4, so I'm not going to go through that process with you because that's just wasting your time. But I will say that this has been pretty interesting learning experience. I got the whole machine set up here in probably 20 minutes, got the bed leveled and was printing a part in probably 30 minutes. It comes with this little octopus right here, and then you know, of course, the first part that you print is your own little octopus. And you know, that was a pretty pain-free process. I have been impressed with a few things here. Its overall build quality is really excellent. The packaging was excellent. Control aspects of being able to control from the LCD here is really nice. They used quality connectors and enclosures, so it's very professionally done. And it works great. But what I want to talk about right now is this part right here. I designed a part. There's a couple sets of parts right there. Get a close look at that. And here's one that is complete, has the top glued on. So this is a part for the bandsaw. So let me take you over there and show you what it's going to be. So over here at the bandsaw, and what the part is, here's the part right here, and you see here's the blade coming out of the back support. And what this part is, it's an air jet to clean the blade off. There's a couple little slots in here. There's a hole sized for an 1/8 inch pipe tap. And basically, this is going to sit right here, and with an air hookup, and as the saw is running, it's going to blow the swarf off the blade down into here, and clean the blade off. So just something I'd been wanting to do, to rig up an air jet, and now I've made the part. So that's the purpose of the video, is not to discuss this, but to discuss the 3D printer. So let's get back over to that. All right, we're back over at the printer, and this right here, I just printed 2 more of these assemblies. This is this air jet assembly there, and I had some of this plastic that I printed. And I got to be honest, it is pretty darn tough. Like I said, I have very little experience with this, with 3D printers. This is ABS that I printed in with just the factory ABS profile, and it is darn tough. It's not metal of any type, but it's a lot tougher than you would expect. The model that I got, the Taz 4, has a heated bed, which is real good for printing a lot of materials. It has a pretty big build volume. It's got basically a 12-inch square platform here, and I think 9 or 10 inches is Z. It is a RepRap compatible unit, which means it's all open source. Came with all the files to print the vast majority of the printer, so which is pretty interesting. And of course, all the software to control it is also open source as well. So all in all, very pleasant experience, and I've been having a lot of fun with it. For little, kind of projects like this, it's really pretty neat. Here's another one that I made. You'll see that I tapped it to take an 1/8-inch pipe, which we'll do for this thing right here. Just a second. You got to be kind of careful because, even though this stuff is fairly tough, like I said, it's not steel or aluminum, and you can break it pretty easily. But I just used a regular 8x27 tap, and tap this stuff pretty. Let me find my wrench. There we go. I will say that getting the printed parts off of the bed of the printer can be rather difficult. They can stick down pretty good. And if you rush yourself and you don't follow proper shop safety practices, this is what you end up with. What that is, besides flying the finger, that's an ER room visit in about 5 stitches, where I sliced the end of my finger while I was trying to get a print off of the bed. My own fault. Ridiculous. Now there's other ways to do. From what I understand, you can 3D print the threads for objects straight into parts, or you can use inserts. Like I said, I have not really dug into that. I just drew this part up in SolidWorks and exported it as an STL file, and then generated the G code for it and printed it. But there you go, the hole's tapped, and there you are. I think it behooves people that do the types of work that machinists do to yeah, see, I figured something out. When you start to hear that click, stop. That means something's getting ready to break. Anyway, there you go. There's the fitting for the air to go in here and blow the swarf off the blade. So let's go back to the computer, and we're going to go over the CAD work for this little jewel here. And then I'll walk you through the process of what you have to do to generate the G-code file. Alright guys, here we are at the computer, and here's the part that I designed right here, what I refer to as the blade air jet. And I guess you can see pretty easily the features here. The air comes in from this side, and then it splits over this inner wall and blows out as a jet along the blade on both sides through a little slot. And there's the hole for the barbed fitting. Not a lot of air going to go through here. This is going to be just a couple of psi. So, excuse me, a little 1/8 MPT barb fitting is fine. So that's how, you know, basically I drew this part. There's not a whole lot to it. There's another part that I did that I also printed that I'm going to show you, and here it is right here. This is the adapter for adapting the power feed to my Herco mill, which is also a project that's been ongoing. And I just completed this CAD here right before I got the printer, and I was drawing up the actual adapter just to make it easier on me when it came to build time. Then I thought to myself, it's like, well, hey, you know, while I got this thing out here, why don't I print it just for grins, right? I mean, one of the great uses for these little things for parts that you can print is prototyping, as far as seeing, you know, if the part's going to fit and behave the way you think it's going to behave. Print it out. So I did. I took it just the way I'd drawn it here, which I had, you know, when I drew it, I had no intentions of 3D printing it. And I said, hey, I'll print this, and then we will, you know, see what it looks like. And I'm going to show you that part too, and just how strong some of these things are. So it's pretty interesting stuff. So let's go back to the other window, which is this air jet. So the steps for me from this point on right here, if I want to print this part out, first thing I got to do is I got to do a file, save as, and then I've got to save this as an STL file, which stands for stereolithography. And there's already one file name saved from this drawing. And then once I have an STL file, what I have to do is run a program called Slicer. And this is an open source program that came with the unit. The unit is a RepRap compatible. So this program, Slicer, again, which I actually have very little experience with. I've got a config file which I'll load here, which is an ABS config file, which has all the settings, basically just the factory default settings. The only thing I did in the ABS config that the factory default config didn't do is I made sure the cooling fan stayed off, because ABS prints better at a higher temperature. So then I can add my objects. So I can come in here and grab this STL file and drop it on this grid here. Represents my build envelope, and then I can just add objects on here. So I can go in there and say add that. Then I can say add the cover, which is that little piece. So then once I have this laid out the way I want, I have all the settings the way I want, what I can do at that time is export this as a G-code file. So I'm going to put an SD card in here, and then I'm going to export this file we just did here as G-code. I'll save it onto the desktop. How about that? Make it easy on myself. And it's bladeairjet.gcode. Hit save, and boop, there you go. It basically takes my 3D images and my 3D objects in the STL format and slices them up, generates all the G code to generate the slices. One of the things I will tell you to, kind of a construction technique. Obviously, I built this as this side, this face here, down on the platter, and everything's built up. Well, in order in SolidWorks for you to be able to import your STL file directly into Slicer and have it oriented the way you want, you need to build your parts against the front plane, right? That's the plane that's going to, when you export your STL file, that's the plane that's going to represent, what you see as the platen or the work surface in the 3D printer. So do your drawings. If you're using SolidWorks, build your objects up off of the front plane. It's not a big deal if you do it off the top plane or the right plane. It's just that before you export, you're going to have to go change the plane, the home plane for the part, in order to get it to orient properly. So let's get this file now that we've exported this G-code file. Let's take this file over to the printer and kick this thing off. All right, we're back down here at the 3D printer, and sorry that that's kind of washing out the image, but what you're looking at is the LCD. There's my hands. Woo. And the SD card goes right in the side. And if you want to print, you just, if you have the machine set up ready to go, you hit print from SD, you choose the G-code file, you hit the button there, and it kicks off and print. But like any good cooking show, I've magically already got that done. So I've already done one of these, and I've got some time-lapse imagery, which I'll show here shortly, which shows these being printed. But here are two of these airjet assemblies that I printed, and they can stick down to the bed pretty well. They're pretty well, and if you get, well, this is what happens if you get in a hurry to try to get something off the bed here, right? But so these two that I've done, in addition to the one that I showed you earlier. So that this print took about 2 hours. Little tricks I've found to getting stuff off. If they have if the part has some flexibility and you take advantage of that, it will help you get parts off the bed without injuring yourself or others. Same here. So, like I said, these things stick down pretty darn good. There we go. As a surface prep on my heated work surface here, I used Elmer's Extreme Glue Stick. This is it's a light purple color. Just when the bed's cool, just a light wiping, and boom, there you go. Anyway, so yeah, I've made 2 more sets of this part. After you're done printing, cleanup is pretty much a breeze. I was just using some of this crud cutter here, and wipe that on, spray it on, let it sit for a second, and then pretty much takes it down spotlessly clean. That's it. Said that the possibilities here are endless. Let's move back over to my traditional location. All right, so here's the one that I made the first one that I made that actually has it's assembled and has the fitting in it. And as you see, basically I just took these two parts, used some plastic cement, like literally model glue, glued that part on there, and voila, there you go. There you can see the detail on the interior versus the drawing that you saw earlier. Prints very cleanly, very nice. I don't have any experience with any other 3D printers of this type, so anyway, needless to say, I'm impressed. I got some prints from an earlier design I was working on, kind of prototyping, and that's about 1/4 of an inch thick. And I'm going to tell you, that stuff is tough. I mean, I can't just break it with my bare hands. So this stuff is really pretty tough. I don't have use of all my fingers right at the moment, but it's a lot tougher than I was expecting. And here's a thin slice of one of the same patterns, and you can see the infill pattern. It does a solid bottom and a solid top, and then it does an infill pattern. You specify what percentage of infill you want. You specify how thick this border, the edge, is going to be, and then you can do things like tell it, oh, every 5 layers I want a solid infill or whatever. But here you go. It is pretty darn tough. You got a little cracking and stuff here. This is obviously a print that was failing and I quit, but I'm pulling on this bad boy, right? It's tough. There's some tough stuff. So that literally is just a couple layers. So pretty impressive. Now let me get the adapter, the other part that I showed you that I drew. There you go. Does a pretty good job of modeling all these features, and I mean, this thing's solid. This is a solid piece, right? Again, this adapter bolts up with like so. These 4 bolt holes bolted to the machine, and then these bolts allow it to bolt to the actual power feed unit. Just let me get that. So here's the power feed unit. One of the features that I drew in here was this nose, this section right here, which is designed to fit inside this ID on the power feed unit. And it actually fits quite nicely with a nice firm fit, and then allows you to basically check your fit up, how the part is going to assemble to your how this part's going to fit into your assembly. Check your diameters and everything, check your spacing. So it works a whole lot better than I expected. It works so good that I'm seriously considering putting some inserts in these tapped holes here and mounting this baby up and using it as the adapter and just seeing if it holds up. I'm just not sure. By the way, that's not blood. That's marinara. So anyway, I'm considering doing that. I don't know. I've got to get some inserts, or make some little inserts to go in there. But I am considering giving this a shot and trying to use the adapter just to see how durable it is, just to see how usable parts are that come off these 3D printers. So there you go. I'm going to exit this video here, and then I'm going to play you some time lapse over the 2-hour time period that it took to print these two airjet assemblies that I made for my, just extras. I just printed them, right? So it took about 2 hours to print those 4 parts, and so I'm going to show you a little time lapse on that. I'm really excited about playing with this because it's been fun. It definitely requires a different thought process than, and I'm not there by any stretch of the imagination. As far as designing in metal versus this, I drew this part, the adapter, and CAD'd this all up before I ever owned the printer. So it's designed to be made out of metal, and I got a piece of stock sitting over there that I was getting ready to make this out of. Probably still going to end up making this out of, but there are things that I do differently now that I think about the process of using the printer. Like with these holes, which are in the metal part supposed to be holes that are drilled and tapped for 5/16 24 fastener. What I would do here is I would have a slot in the part that you could slip a nut into the plastic so that you could run a fastener through the hole and into a nut. That's kind of the 3D printing way of adapting to metallic fasteners. Like I said, my brain is not there. It is firmly stuck in metallic design mode. I got 2 of these, 2 more sets of these. If anybody thinks that one of these little air jet assemblies could be adapted to your bandsaw and you want to give it a shot, the first 2 emails that hit my inbox with a mailing address will get these sent out, as a little gift to thank you for watching my video and for subscribing to my channel. Please subscribe if you haven't already, and like and comment prolifically if you like it or not. One of the things I've said many times is as much fun as I get out of making videos and presenting videos to people and helping other people with their shop issues, I get more out of this than I ever thought possible. It's a great exchange. It's a great community. So anyway, first 2 emails that hit my inbox with a shipping address, get these babies right here. And now enjoy the time-lapse video on the printing of this, and be safe in the shop. Be safe. Don't do this. And have a happy and safe New Year, and I'll be back to you soon.